All right, so if you have the PowerPoint slides, it's page 112 is the data. I'm going to throw it up here as well. But if you want to look, that's the table we're going to use. It's just big. But we'll get there in a minute. Okay, so last time we did standard deviation and mean, median, and mode with regular data. Today we're going to do the same thing, but we have grouped data instead. So same idea. Come back to my data set in a little bit. Oh my goodness, stop it. Okay, so I'm going to give us all the equations and then we're going to use them. It's easiest to deal with it in this way. So our mean is the sum of xi, fi, all over sum of fi, xi equals midpoint of interval f sub I is the frequency of the same interval. So I'll give everybody a sec. Should say the ith interval. We're going to come back to our data set, but if this is our data, our interval, the first one goes from 50 to 74.99. I would probably just use 75 for my calculations. Works the same way. So that's our midpoint. Oh, I forgot my calculator today. I think this hard today. 50 plus 75 over 2. So this would give us an x sub 1, since it's our first interval, of 62.5. And our frequency for that category is the second list of numbers. So our F1 would be 1. We will use this example after I get the other things. So just showing where everything comes from. So once it's time, we can do that. Okay. Do I need that? I do not. Okay. We also have a weighted mean. So I think of your weighted mean as like your grade point average, how you figure out what your GPA is. It is the best example of a weighted mean I have. So it's a very similar formula. Use a little sub W. So sum of x sub I, W sub I, all over, not the sum of the weights, I wrote that wrong. Our frequency, essentially, so all of our x values. So if this was a GPA problem, we'll pause and do a quick example with this one. Let's say you have, for your A's, you have 8 credits. You have 3 credits worth of B's, and sad, you got 3 credits worth of C's. An A is worth 4.0. A B is worth 3.0. A C is 2.0. We want to figure out the weighted mean. Our total number of credits, 16. So I'm going to take 4 times 8 plus 3 times 3 plus 5 times 2 all over 16. And I'm really sad I forgot my calculator today. gives me 51 over 16. So we get a GPA of 3.1, call it 9. So multiply each category, divide by the number of credits in our case. Has anybody calculated their GPA before? No? Okay, I was obsessed with that when I went through college because I had a goal amount and I was just shy of it. Sad. Okay, so that's how we do that. I'm gonna leave weighted mean alone. Just wanted to introduce it. Not gonna worry about that more. The other things we want to do is our standard deviation. So we have the generic formula, which I will show you and we will never use again, as usual. Xi minus mu squared times f sub I all over sum of f sub I. So that is our population standard deviation. The one we are going to use is this guy. So we get the sum x sub I minus x bar squared times our frequency all over the sum of our frequency. That is what we're going to use. Excuse me. Okay, I'm going to shorten this data set because it's really long. I want to do this. Oh, you don't want to close stress. There we go. Okay. This is my very terrible looking data set. That should be a 24.99. And then we would go up to, it's every 25, so 149.99. Okay, so our intervals are on the left, our frequency is on the right. The first thing I want to do is sum up my frequency. So I know what the sum is. In this case, I get 18. So I'm going to put down here in pink sum of f sub I equals 18. Okay. The next bit of this is a process, kind of like our standard deviation was before. So I'm going to walk through how we do this. Step one is we want to find our mean. So I'm going to take the midpoint of each interval. I'm going to use the whole number instead of, so I'm going to use 50 to 75 rather than 74.99 because it'll make our numbers nicer. So my first midpoint, take 50 plus 75, that's not 75, times 1/2. And we're going to do this for each category. You take the high value plus the low value divided by 2. I know I just did this, but I promptly forgot. So my first one, I get 62.5. I'm going to call this X midpoint. All right, and then 75 plus 100 over 2, 87.5. 100 plus 125 over, no, 2, 112. And finally, 125 plus 150, right? Yep. over 2, 137.5. To show where that came from. That's a chart. Okay. That's our step 1. The next thing we're going to do is take our F column times our new X sub M column. So this is F, X, M. So our first one, 62.5. Our second one is 0. That's lovely. Times 10. 1,375 times 7. 787.5. So take your F times your X sub M, your midpoint, get a new column, add up that column. I got 2225. So sum F, excuse me, X, I, F, I, 2225. We are one step from finding our mean. So I'm going to do that. My X bar is 2,222.25. Wow. Divided by 18. I really need more coffee today. And I get 123.6. This mean is really, really high, but if you look at our frequencies, where is all our data dumped? Our biggest category of data is that last one. And it's more than half of our data is in that set. So it makes sense that our mean would be kind of high. If I had the full data set, it would have looked better, but that was like 10 categories. Nobody wants to do that today. Okay. We have our mean. So now we have to do our standard deviation. So the next thing I want to do, I'm going to copy my list of numbers since I don't have a lot of space for it here. I'm going to copy this column. I'm going to make 2 more categories or 2 more columns of data. So my next column is going to be our X sub M, black, minus our F, and then we're going to square these data values. And then my last one, X sub M minus F squared times F. And our mean is above. Okay. So the first thing I'm going to do is I'm going to take 62.5 minus our 123.6. So it's going to give me negative 61.1. And now I'm going to square that. Turn you sideways, squared. So 3733.21. Same thing, but 87.5 this time. 7. I really didn't need to do this one. Same thing there. I get 123.21. Last one, 37.5. 193.21. Just to show where that came from. Worst of this is almost behind us. So I take my my midpoint minus my mean. I wrote that wrong. That should be mean. X bar squared. That's better. Now I'm going to multiply each one of those times my frequency. So my first category is nice, as is my second. Get a big old 0 on that one. Times 10, 1, 3, 2, 1. And my last one is the pain, 123.21 times 7. 862.47. So I just took my F times my column I made, and now I'm going to add that column. So plus 1, that is not a 1, 193, 2.1 plus 3733.21 gives me a very lovely number, 6527.78. Hopefully. I have all I need to do to fill in my final equation and just calculate it. So my standard deviation is the square root. This big number we just found is on the top. Over my frequency minus 1. So getting to this point is the hard part. Once we're here, it's not so bad. 6527.78 over 17. 383.987. There is more digits here. I'm just not writing them down. The square root. Oh. 383.987. I get about 19.6. I want to say on the test, they're not going to make you do all of these steps just because that's a lot of steps. And there's so many places for like little errors. Honestly, if I were to do this myself for not on a screen, I would probably throw it in a spreadsheet and have it do the math for me. I'd take my low value, my high value, have a subtraction column, a frequency, and then just keep making columns across. And then it'll do everything except for the last step of plugging it into the equation. And the whole thing, that's the easy part. Getting all the bits and pieces is the harder bit. Okay. I'm going to pause this a sec. Screen. All right, sections 3, 4, and 3, 5 are much nicer than the previous two sections, and they're very related. We're going to use a lot of the 3, 4, some of the 3, 4 stuff for 3, 5. So 3, 4 is called position and outliers. Our position is something called a Z-score. Z-scores will come back to haunt us later. Luckily, it's an easy formula. I don't often call formulas easy, but this is. Learn it now. We'll talk more about why we care later. We have to build up a little more math first. You take your data value minus your mean, divide it by your standard deviation. What this measures is how many standard deviations are we from the mean. At the moment, you don't care, but we will care. Well, you may never care. The class as a general and as a whole will care later on. It'll come back at us. So for now, that's our score. Don't worry about it more than that. It is related to something called a percentile. Which will again come back when we talk about it again. But most people are at least somewhat familiar with percentiles. If you've ever taken a standardized test, so ACT, SAT, etc., they probably give you your percentile score. What that does is take everyone who's taken the test and say where you rank. You know, did you score better than 50%? Did you score better than 75%? Where are you amongst everyone else who's taken the test? So this is kind of your score. So your ranked score. Another thing, if you ever have a kid and you take them into their doctor visits when they're under 10-ish, they always give you their percentile for height and weight. So if your kid is in the 70th percentile, that means for, say, height, your kid is taller than 70% of kids the same age. That means 30% are taller than your kid. That sort of thing. So it just tells you, you know, where your kid is compared to everybody else that's similar. So it's a comparison technique. We're going to leave that for now. The next thing we're doing is quartiles. And this will come back for next section too. For a quartile, we're splitting your data up into 4 data sets, or 4 little groups. And funnily enough, we report 5 numbers for our quartiles. So that seems kind of funny to me, but we have our min, which is our Q sub 0, I'm going to call it. We have Q1, which we'll talk about in a sec. Our median is our Q2. Q3 is, again, we'll come back to that in a sec. And our max is our Q4. These 2 are important. I just don't have good names for them at the moment. So what we do is we take our data and we order it from smallest to largest. You're going to find your minimum, your maximum, and median as we do. So we'll find those 3 numbers. And then we're going to look at from the minimum to the median. So the lower bounds or the lower numbers, we're going to find the median of that. So we're going to split our data in half and find the median. And then we do the same thing for the high values. We split our data in half and find the median there. So we can find the median 3 times, sort of. You have table 16, which is in front of you here. We're going to find the quartiles for this. So take a sec, list your data. There's 18 things there. See if you can find the quartiles, and then I'll talk it up here, but find your min, your max, your median, and then like your other medians. Okay. Funky ones. So take a sec and try that. Yeah, hang on. Sorry, it's loud up there. I forgot to pull this, whoops. All right, so here's our data from the sheet. It's in order this way. We have an even number. So to find our median, we need to take the mean of the middle two. So 1657 plus 1953 divided by 2. So in this case, my median is 1805. My minimum, 180. My maximum is 147. Okay. Those three values we should be familiar with. We did them last time. Our Q1 and our Q3 are a little harder to find. So for our Q1, I take the lower half of my data. So which is this. Can you find the median of that half of the data? Well, we have 9 values. So 1, 2, 3, 4, 5. That's our median of the lower. Median of the upper will be in the same place since I'm symmetric. So 735 and 4668. We will graph this next section, but we can put this on a number line and mark everything. So we'll put our min, lower quartile, median, upper quartile, max. We're gonna do that. It's called a 5 box plot. That's what it's called. So we'll play with that. The last thing on this section we care about is the inner quartile range. Called the IQR for the obvious reasons. And to find this, it's a pretty straightforward measure again. Those are always nice. Q3 minus Q1. And we will need this measure again for next section. So we take our quartile 3 minus our quartile 1, and that's our IQR. Should be a 1. So for our example above, 4668 minus 735. I could probably do that in my head, but that would embarrass myself, so let's not. 4668 minus 735 gives me 393. On its own, that's kind of a meaningless number. But we can use it to help us find outliers via something called fences. For our lower fence, we're going to take our quartile 1 value minus 1.5 times our IQR number. And so what this tells us, anything that's lower than this lower fence is a really small outlier. Our upper fence Q3 plus 1.5 times our IQR. And again, anything higher than this value is a high outlier. So we want to be in between these to be safe. So for our data set we just used, we had our Q1 was 735. Why can I never write the 1? There we go. Q3 is 4668, and our IQR was 3933. Q1 735 minus 1.5 times 3933. Plug it in and we get a really little number. So we get a fairly small number. It's negative. So we can't have any low outliers in this case because all of our numbers were positive. Sometimes we can. Our upper fence, we do a very similar process. This should be 4668 plus 1.5 times our 3933. And I said this should give us 10,567.5. So anything higher than that is a high outlier. Anything lower than our other one is a low outlier. If you look at the data set I gave you, we actually do have a high outlier. Data set. And say hi. Outlier. So an outlier, can't remember if we talked about this or not, it is a number that is significantly different from our other ones. It's either a lot higher or a lot lower than everybody else, because most of the numbers should be near the center. It's the cool thing about that. Okay, we are doing good on time. 3.5 is our 5-number summary and a box plot. We have all of the tools to do this already. Really, we could have smushed these into the same section. And splits. Okay. No new concepts here, just a new way to present our data, which looks kind of cool. We need our min, our Q1, our median. Q3 and our max. You can add your fences. I find I usually don't need to, but we can do that. And then we're going to plot this. So we're going to make a number line that's hopefully to scale or close enough. This is your min. This is your max. Our median is in the middle. This is our Q1 number. And whatever this one ends up is our Q3 number. And we just make it look pretty. It's just a graphic showing the center of our data. Kind of, is it a high median? Is it low? Just gives us a picture. Pictures are nice. Okay. The data set I gave you is not an order set. So 161, so the bottom data set, there's actually two data sets here. There's flight and control. I'm going to do flight with you, and then I want you to try control on your own because this really takes up the last two sections together and shows you can hit it. So I'm going to try to put these in order as I go. That is always a recipe for disaster, but we'll try. $6.87. Already messed up. 6.39. Any other sixes? 6. Wow. Okay. It's all my sixes, hopefully. 7.0. Any other sevens? 7.43. Oops. I will fix this. Any other sevens? Do I have any eights? Yes, 8.03. And 8.59. 8.8. Can I do 8.64? And hopefully nines. I have 2, 9.3, and 9.7. 1, 2, 3, 4, 5, 6, 7. 10. No. Yeah, 14. Okay. Ooh. We have an even number again. It's always a bummer. All right, our min and our max are just labels for us. Our median, we take the mean of the middle two for us, since we have an even number. 7.54 plus 7.89 divided by 2. My median is 7.715. Okay. Quartile 2, we take the minimum and the lower median. Find its, which should be 7.0. No. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Yeah. So those are Q1 value. 1, 2, 3, 4. There's our Q3 value. So I'm lower median, the upper median. Now I number line this. So my lowest number is 6 and a bit. My highest number is a little less than 10. So I want to go from 6 to 10. This is 6, 7, 8, 9, 10. We can do a little better. 7, 8, 9, 10. So that's just my number line. I'm tired of pink. Give me blue. My minimum hits at 6.39, so not quite 6.5. So here-ish looks good for my, thank you for that. That looks good for my minimum. My maximum is 9.79, so here-ish for my max. Median is 7.7, so call it there for my median. I'm gonna connect these with a nice little line. All right, quartile 1 is at exactly 7. Quartile 3 is 8.6, so here-ish. And now I box them. Ooh. You can color this in or not. If I darken it, I can. I'm gonna leave it. Wait. I have a highlighter. Oh, that's nice. All right, so we have our 5-plot summary, our box plot. Now, you have a second set of data, the control. What I want you to do is do the same thing we did here. So order them min to max, find the number summary, and on that same picture you drew, assuming you drew one, draw the control data below it so you can compare them. So I'm gonna pause the video and let everyone do their thing. I'll walk around and see if we need help with that. And then we'll draw the picture and go from there. See if I can actually pause it this time. Oh my goodness. My throat. Eating via Google Sheet, just so I didn't have to order everything. For me, that's the hardest part. So I found that the minimum should be 6.99. Q1 hits at 7.44, median 8.565, Q3 9.14, and the max is 9.94. So now I'm going to graph those. And let's use pink just to keep it different. All right, 6.99. My minimum, my max is 9.4, so that's pretty high. That is here-ish. Median is 8.5. Here-ish. And Q3 is 9.14, which is here-ish. Yeah, that's not nice. So we get a 5-point summary or box plot. The things on the side are called whiskers, if you're curious. I just think that's incredibly cute, you know, because your pets have whiskers often. So you have the box and its whiskers. We can compare. So you can tell that our pink data is a lot higher on average, even though the maximums are similar. Everything is scooted over farther to the right, so those numbers are higher. That's not enough to make broad generalizations, but it gives you a nice picture of your data just to say, okay, I see a trend here. Let's dig into it deeper and see what else we can find. So that's helpful with those. Okay, this is the end of chapter 3. Your test is going to cover 1, 2, and 3. I think it's live, but I'll double check. So I'm going to talk more about that once I stop the video because this is class specific, but you should have all of the information for that. You should be ready to go. I highly recommend you do your homework before doing the test. So I'm going to stop this. completely.